Just a reminder before we do example 4 is a difference of cubes is equal to a subtract b times a squared plus a times b plus b squared. We remembered how to factor a difference of cubes using SOAP. S, the first sign is the same as the original. O, the second sign is the opposite. And the last sign is always positive. So now let's look at example 4. The limit as x approaches -3 of x cubed subtract 1 over x plus 3. We cannot use direct substitution. If I put -3 in for x, I get -3 plus 3, which is 0 at the bottom of a fraction. So the next thing I'm going to do is factor and see if anything cancels. So when I factor the numerator, which is the difference of cubes, I get x minus 1 times x squared plus x plus 1 over x plus 3. You can see that nothing in the numerator is going to cancel with the denominator. Because of that, there's nothing else I can do, and so the limit is equal to dne. And dne stands for does not exist. Example 5 is what we refer to as a one-sided limit. The limit as x approaches 2 from the right. See that little plus? That means from the right-hand side. So we're going to find the limit as x approaches 2 from the right of f of x. F of x this time is a piecewise function. And I graphed the piecewise function so you could get a visual of what's happening. So down here, reminder of how to graph a piecewise function. The red is the x squared. And so if you put in 0 squared is 0, 1 squared is 1, 2 squared is 4, and then do you notice x is less than or equal to 2? So this is a closed-in point, and I only want everything smaller than 2. So that's this part of the graph here. The other piece is this green line, which is a line, 3x subtract 1. So I started at -1 for the y-intercept, and I did rise 1, 2, 3 over run, which is here. Now that is not in my domain because my domain is greater than 2. So I did rise over run again, rise 1, 2, 3, and run 1. Notice it's not including 2, so I did an open circle, and I drew this piece of the graph. Now the question is asking us when, where, or what is the limit as x approaches 2 from the right. So this is the right-hand side of the graph. And what you're going to be doing is we are going to approach 2. So here is 2, and we're going to be on the right-hand side. So when I'm here, I'm up here on my function at, let's see, 2, 3, 4, 5. At 5, I'm up here on my function. At 4, I'm up here on my function. So I'm trying to see where I'm approaching. At 3, I'm here. And you can see I'm coming in to the number 2 from the right-hand side. So at 2, I'm here. Now I know it's undefined, but I'm not finding f of 2. I'm finding where the function is approaching. And it's approaching when x is 2, f of x is approaching 5. So therefore, the limit as x approaches 2 from the right-hand side of the function f of x, which is this piecewise function, is equal to 5. Now there's one other way that I can do this, and that's by using substitution. So if you want to use substitution, what you'll do is you have to pick the piece that is on the right side of 2, or upper bound. So we are going to have to use the linear function if I'm going to use substitution. So what I would do is the limit as x approaches 2 from the right of f of x is going to be 3, and in place of x, I'm going to put 2, subtract 1, and 6 subtract 1 equals 5. So the important thing is that you use the correct piece to plug in if you're going to use direct substitution in order to solve this problem. I do want to point out, if the problem was asking you for the limit as x approaches 2, and I didn't specify the right-hand side, then f of x, the limit as x approaches 2 of f of x is going to equal, do you know? Does not exist. Because from the left side, the limit would be 4, and from the right side, the limit is 5. And you have to approach the same value from the left and the right side in order for the limit to exist. In example 6, the limit as x approaches 2 from the left-hand side. How do I know it's the left-hand side? It's this little minus right there. So how do I find the limit as x approaches 2 from the left of the square root of x minus 2? Let me just remind you of what the graph looks like. So here's the graph. We know that y equals the square root of x, got shifted opposite of what you think to the right 2. So I shifted the graph to the right 2. Here's the graph. Now the problem we have with this graph is there's no function over here. So I cannot approach 2 from the left-hand side because there's no function for me to approach. Therefore, the limit as x approaches 2 from the left-hand side is going to equal does not exist. Here's a reminder one more time, the difference between a one-sided limit, which is from the left or the right side, versus a two-sided limit. So if it has the limit as x approaches c of f of x, then we know that the limit from the left side and the right side have to be the same in order for the limit to exist. Now let's answer the following questions about example 7 to see if you understand the limits. We have a piecewise function that jumps. So the function is here, and then the function jumps up here, and it's actually equal here, and then you've got this piece. So looking at this piecewise function, let's review the limits. A, the limit as x approaches 1 from the left. Again, that little negative right here means from the left. So what we're doing is we're coming in from the left-hand side. And as x is approaching 1 from the left-hand side, it looks like f of x is approaching, what's the y value? Is -1. Again, we don't care what it actually equals, we just care what it's approaching. That's what the limit is. Let's look at B. The limit as x approaches 1 from the right. See the little plus means from the right-hand side. So now x is approaching 1 from the right side or the upper bound side. So as x is getting closer and closer and closer and closer to 1, f of x is approaching, that's right, 2. All right, the limit as x approaches 1. Now, this does not have a plus or a minus, so that means we are approaching from both the left side and the right side. Since those numbers are different, from the left side, as x is getting closer and closer to 1, f of x is getting closer and closer to -1. From the right side, as x is getting closer and closer to 1, f of x is staying at 2. Therefore, the limit does not exist. Did you guess it right? I hope so. All right, last one. F of 1. This means we are going to evaluate the graph. We're not finding the limit. We're just figuring out what is f of 1. So when x is 1, we come over to 1, then f of x is equal to that point right there, which is at 1.